We're on the bottom of page 14 in the note pack looking at an example where finally we'll follow all 8 steps. BJ, once again, step number 1, just repeat what you said. What are we to do first in the 8-step process?
Write separate half reactions.
Sounds perfect. Nate, help me decide when I'm dividing things into 2 half reactions, what will I start placing together? Help me write a first half reaction.
MnO4 negative, Mn plus 2.
That's exactly right. In other words, those elements other than oxygens and hydrogens, I better account for them in the same half reaction. It would be impossible to balance an iron and a manganese in different halves. So in a first half reaction, we have permanganate, which is the name of MnO4 negative, forming its ion of Mn plus 2. Taylor, what would the second half reaction look like for this particular equation? Perfect. Claire, just a little question. Repeat for me step number 1 found at the top of page 14. Check, we just did. We took this equation we're being asked to balance and broke it into 2 halves. Thank you. Nicole, what does rule number 2 say? All right. In the first half reaction, we're being asked to balance the manganese. Looks good. Second half reaction, we're being asked to balance the irons. They look good. Rule number 2, all set. Nate, help me read number 3.
Balance oxygen using water.
Thank you. To the first half reaction, McKenna, we need to balance the permanganate's oxygen. What would I do to balance that? And I think you said H2O, although that trailed off. That's part I didn't hear. Perfect. I balance the oxygens by placing the water on the right-hand side. Step 1, broke it in half. Step 2, the MNs and the FEs all set. Step 3, we've got the oxygen balance by placing waters. Brett, read for us step number 4.
Balance H using H plus.
Thank you. Notice, by the way, I skipped the second one. I should have made a comment there. There were no oxygens or hydrogens, so I kind of went right by that. Casey, in the first half reaction, we added water to the right-hand side. We got to now back the bus up. Help me balance those hydrogens.
H plus.
Perfect. And I like how you remembered to tell me that the hydrogens were indeed positive. We balanced the hydrogen from the water with the protons. Protons carry a positive charge. Excellent. Rule 5, John says what again?
Valence charge using E negative.
All right, so now we've got to decide what the charge is so far on both sides. Troy, when I look at the first half reaction, on the left side only, what is the net charge so far? With 8 positives and 1 negative? Yeah, good work. +7. Good. Emily, let's look at the right-hand side of that first half reaction. What is the net charge so far?
+2.
Perfect. Aaron, between the left and the right, simple question, which one is the more positive side? Perfect, yep. To the more positive side, that's the place where the electrons will go. So the important thing to remember is we don't make them both become 0, we just make them become the same charge. So to the more positive side, Marissa, how many electrons should I place?
5.
Excellent. 8 electrons to create neutrals. So now, instead of +7, we have it down to +2s. 5. That's what we said. Thank you for catching that, everyone. That's what it says. Perfect. 5 electrons, 8 hydrogens, permanganates makes the manganese +2 and water. Now we're both down to +2s. All right. Let's do the same because finally we have something to do for the second half reaction. Courtney, what is the net charge so far on the left side for our iron half reaction? Perfect. And Alex over here? Perfect. BJ, to the more positive side, how many electrons should I place?
1.
On which side?
The right.
Perfect. And now both have become a positive 2. Nate, read for us back to the top there. What does rule number 6 say?
Multiply equations to make electrons equal.
So Leo has to equal Ger. Taylor, if the first one is gaining 5 and the second one is losing 1, what would I do to distribute to make electrons gained equal electrons lost? Beautiful. We have to distribute a 5 through the second half reaction so that 5 electrons gained will indeed equal and match the 5 lost. Alrighty. Oh, hey, Claire, the first half reaction, I should have said, we might as well just jot it down. It's gaining electrons as a reactant. We put them on the left-hand side. Does that sound like a Leo or a Ger? It is indeed. Gaining electrons is a reduction half reaction. On the second half reaction, Nicole, what would we label the iron to iron plus 3? It is indeed an oxidation half reaction. Perfect. All right. So we have indeed multiplied equations to make the electrons equal. That was step 6. Nate, back to the reading part. Read for us step 7. Okie doke. So just carrying that arrow right down, everything to the left goes down to the left, everything on the right will be placed here, and if the electrons don't cancel, it's back to the drawing board, because that's the whole goal, is to get the electrons to go through. So carrying down everything we have so far, we have 5 negative electrons and 8 positive protons and a permanganate, MnO4, -1. That's the first half reaction. Let's add that together to the second half reaction, and we'll distribute the 5 at the same time. So we have 5 irons that are a positive 2 charge. Same strategy over on the right side, the product side. We have an Mn plus 2, and we have some waters, 4 of them. We have to distribute the 5 when we add the second half, so now I have 5 irons with a plus 3, and indeed 5 electrons. We notice the electrons can be simplified. McKenna, do you see anything else that can be simplified as a double check? Me either. This indeed is simplified as far as we can go. And Brett, one more rule to read, number 8.
Check that charges and elements are balanced.
All right, it's just good business, double check. On the left side, let's count the total charge. Casey, help me add so far on the left side what the net charge ends up being, with 8 positive protons, 1 permanganate, and 5 irons at a plus 2. 8 positives, 1 negative, and we have a 10. There we go. John, let's do the same thing over here. What do we end up with? I think we got it. Yeah, 2 and 5 units of a plus 3. 5 times 3 is 15. So that looks good. The charges are matching. That's a double check. And we should just be sure that we have the same number of atoms. Troy, let's count hydrogens on each side. How many do you see?
8.
That looks good. Emily, how many MNs do you see?
1.
Yep, they're matching. Perfect. Erin, how many total oxygens on each side?
4.
Oh, yeah. And we've got one more check, Marissa. That's the irons. How many of each?
1.
I think we look good. Let's give ourselves a big old chemistry star, because it just feels good. Our balanced equation, through an 8-step process, 8 hydrogen ions with a permanganate, 5 iron plus 2s, form an Mn plus 2, 4 waters, and 5 irons with a plus 3. 8 steps to balance a redox. Let me pause here.